those days it was King Charles II. And in his own words, he founded the observatory to find so much desired longitude papers. So you might think, well, what about the other one, latitude? There are two parts to actually finding where you are, latitude and longitude. Why didn't the king care about latitude? And actually, I'll just see if you're all awake by I'll give you one little question, which is, shut your eyes, no cheating, and draw lines of latitude in the air in front of you. Come on, everyone. Yeah, very good. Excellent, excellent. What a good class. So yes, lines of latitude, those are the horizontal lines. Why didn't the king care about that? Because they could already find their latitude pretty well. Latitude tells you how far north or south you are. Yes. Oh, I see. That's a good idea. Yeah. So a flat surface will give you horizontal lines. Good tip. And so, longitude though, very difficult to find. But of course they knew, you probably all know, longitude is pretty much the same thing as the time difference between the different parts of our world, because it's rotating once every 24 hours. Is anyone from a different time zone? Shout out the number of hours then, different, from Greenwich Mean Time. One? No, that's not enough. Come on,
10.
Oh dear, I was really hoping for something bigger than 1, but also something that I could very easily divide into 24. But I can't do 5 into 24, that gives a very vulgar fraction answer, doesn't it? So I'm going to have to go with my fallback, which is the island of Barbados. The island of Barbados is 4 hours behind Greenwich Mean Time. If it's behind Greenwich Mean Time, it means it's west, because they're still waiting for the sun to come over, so we know it's west. 4 into 24 goes 6, and so the island of Barbados is 1/6 of the way around the world to the west. So in terms of longitude, we divide 360 by 6, and we get 60. So the longitude of Barbados is 60 degrees west. So of course they knew the answer would be, take a clock with you on board the ship, and keep that clock on your home time. You set off from Greenwich, keep your clock on Greenwich time. Because you always know local time from the midday sun. When the sun is at its highest point, it's 12 o'clock noon where you are. So you know local time, wherever you are. You look at the clock with you, and you know the time in Greenwich. So you know the time difference. So you know your longitude. Well, this observatory was founded in 1675. The most accurate time to clock in those days to keep time to about 5 seconds plus or minus a day. So on a long voyage, that would mean you didn't know where you were. Much worse than that, they're all pendulum clocks. So how can the pendulum clock possibly work properly on a moving ship? Couldn't, and so they really gave up the idea of a clock solution. Until in 1674, a Frenchman visiting London said to one of the king's girlfriends, I have the answer to the problem of longitude. So that king's girlfriend went to the king and said, this man has the answer to the problem of longitude. She was also French, by the way. The king, as I said, it's Charles II, he had many girlfriends.
Charles II.
And so a meeting was arranged, and that Frenchman explained the so-called lunar distance method of finding longitude. Lunar as in moon, using the idea that the moon orbits the Earth once a month in a very regular way. So you should be able to predict for months or years ahead exactly where the moon will be in the sky at any moment in time. So to use the method, all you have to do, or really it's all you have to do, is create a series of predictions of the moon's position and say what the time will be at that moment, for example in Greenwich. So that if you see the moon, measure its position, look for that exact position, and then you know the time in Greenwich. You know the time difference, so you know your longitude. What they meant by the moon's position or lunar distance, they meant the angle between the moon and a bright star, identifiable bright star, or even between the moon and the sun. So I imagine the king was very excited when he heard about this and said, right, start preparing those tables. And they had to say, sorry, your majesty, you can't start yet. We know the moon's motion is regular, but we're still working on the maps. Secondly, our measuring instruments aren't good enough. Those angles would have to be measured very precisely. And our instruments aren't up to it, especially if you're trying to use them on board a moving ship. Thirdly, and worst of all, our star maps aren't accurate, so we can't give a precise prediction of the angle between the moon and a star because we don't know the positions of the stars sufficiently accurately. But a bright young man then piped up and said, but your majesty, if you build an observatory, within a couple of years we'll improve our star maps and then we can start preparing those tables. The king said, an excellent idea. I'll build an observatory. I can donate some land from my manor of Greenwich. No expense spared, as long as it costs less than 500 quid. So Christopher Wren, the great architect, was brought in. He built the Royal Observatory Greenwich and managed to keep almost within budget. The final bill for the place was £520, 9 shillings and a penny.
Wow.
And within a couple of years, that young man who first suggested the idea, John Flamstead, was installed here as the very first astronomer royal.
Wow.
And so, have any of you already been up in the Octagon Room?
Yeah.
If you had, you would have read about or noticed a snag that Flamstead came across as soon as he moved in. What Flamstead had to do for his star maps, he had to set up his telescope on a north-south line, which is always called a meridian, wherever it is. Set up his telescope on a north-south line and measure for each star the angle that the telescope is at and the exact moment in time when that star passes the crosshair of the telescope. Well, the snag that Flamstead came across in that room, which is clearly designed to be the observing chamber of the place, is that there isn't a window pointing north, or a corresponding window pointing south. So Flamstead couldn't work up there. But he wasn't put out. He did what any normal bloke would do. He built himself a shed in the garden. Sadly, that shed is no longer here, but we think we know where it was. If you notice, just after you bought your ticket, just before you come out the door to the garden, there's a strip just inside the door frame, and it's marking the position of Flamstead Meridian. Flamstead was succeeded as Astronomer Royal by Edmund Halley, he of Halley's Comet fame, and Halley set up his telescope just by that drain pipe over there. Can you see there's a similar strip in the wall just next to the drain pipe? The drain pipe wasn't there at the time, by the way, and the building wasn't quite the same at the time, but that's where Halley set up his telescope. And then when you look round, you can see there are other meridian lines. Each subsequent Astronomer Royal tended to predict bigger and better telescopes, but they usually left the previous telescope where it had eight. No point just throwing it away, it could be used by the assistant astronomer royal. And so you can see these different meridian lines along the face of that building, right up until you get to the so-called prime meridian. That's the one that was in use in 1884. That's when there was a conference in Washington, in the United States, to determine once and for all where should the zero line of longitude be for the world. Well, Flamstead was a bit hopeful. It didn't take him a couple of years to produce his star maps. It was a lifetime's work, and his star maps weren't properly published until after his death. And the very first Greenwich nautical almanac, that was that list of lunar distances set against Greenwich times, the very first one wasn't produced till 1767, so nearly 100 years after the place was built. But once it appeared, it very soon became the publication of choice for mariners all over the world, such that by 1884, it was estimated that over 70% of the world's shipping that could actually find their longitude, over 70% of them were using the Greenwich nautical almanac. Or maybe that's just what the British delegation claimed at that conference. But for whatever reason, those delegates voted overwhelmingly for henceforward that line over there to be the zero line